Hello and welcome to the screencast on Earth's Layers, Chapter 1.1. Before we begin, make sure that you have your science notebook out and that you have set it up in Cornell note fashion. If you don't remember how to draw the lines, go ahead and look at the example. On the left-hand side, draw a line about an inch from the red line. On the bottom, count up 5 lines and draw a line. And then your main section will be where your notes are. All right, let's begin when you are ready. Before we begin, go ahead and make sure that you have your title for your notes, which is Chapter 1.1, Earth Has Several Layers. The Earth basically has 4 layers. The innermost layer is the inner core. The second is the outer core. The third is the mantle. And the fourth is the crust. So go ahead and write down those notes and draw yourself a picture next to those notes so that you can label those. And please pay attention to how thick the layers are. The crust is actually the very, very thinnest, and then the mantle is the thickest area. So how in the world do scientists know what the interior of Earth is like? I mean, certainly we've never been able to look in there or to dig down into it. Well, what happens is they study the energy from earthquakes or underground explosions that they set off on purpose. And the energy travels through the Earth kind of like ripples moving through a pond. The energy moves slower through less dense materials, like liquids, and a lot faster through materials that are solid or more dense. And this way, scientists can infer or make an educated guess about what each layer is made of and how thick they are. Click on the link where it says, let's see how this works, and there's a little bit of a simulation there to show you how that works. Come back to me when you're finished. The other thing that we've learned is that starting from the crust, moving towards the center of Earth, towards the core, that the pressure and temperature increase and the layers become much more dense, or things are packed together, much more closely together as you go further into the Earth. Now let's take a look at what each of the individual layers are like, starting with the inner core. The inner core is actually a ball of hot, solid metal. Even though the inside of Earth is the hottest, it also has the most pressure. And because of that intense pressure, something that's a liquid actually isn't allowed to become a liquid. It stays a solid. So the high pressure keeps metal solid despite the intense heat. The layer that surrounds the inner core is called the outer core. Now, the outer core is actually liquid, a liquid metal. Because there is less pressure, because we're going towards the crust, there's less pressure, it allows the material to become a liquid like it should be. So lower temperature and pressure allows the metal to remain a liquid. So again, because the inner core has so much pressure, even though it's the hottest part of Earth, it actually, because of that pressure, is not allowed to become a liquid. It stays a solid. But as you go out, there's a little bit less pressure and a lower temperature, and therefore that layer will become liquid. Our next layer is the mantle. The mantle is Earth's thickest layer at 1,700 miles. And it is made of hot rock. So it's not solid rock like the crust, but it's not a liquid. It's somewhere in between. Because the mantle is so thick, the top of the mantle is actually cooler and more rigid than when you go towards the center of Earth. So the middle of the mantle is actually soft and hot. It's kind of like a tar. It's not solid, it's not liquid, it's somewhere in between. The crust is our fourth layer, and it is the outer layer of Earth. It is the thinnest of all the layers, and it is a layer of cool rock. At its thinnest point, it's about 3 miles thick, and at its thickest, it's about 30 miles thick. It is home to all life, so all living things live on the crust. There are two types of crust. The first type of crust is called continental crust, and as you may guess, it includes all of the continents, which there are 7, and all of the major islands. Now, this type of crust is thicker than the other crust we're going to talk about, but it's less dense, meaning that it's not as closely packed together as the second crust we're going to talk about. And all continental crust is located above ocean water. The second type of crust is called oceanic crust, and it includes all the crust that is on the ocean floor. It is anything that is underneath the ocean is considered oceanic crust. This type of crust is thinner because it's actually younger, which we'll talk about later, but it's much more dense. Oceanic crust does not include any crust that is located under a lake or a pond. It needs to be a major source of water like an ocean or a sea. And here, this picture shows you where oceanic crust is located and where continental crust is located. So as you can see, continental crust is above the ocean water, and then oceanic crust is below the water. Now we also have two kind of special layers that combine the major layers that we've been talking about. And one of those is called the lithosphere. Try and say that one with me. Lithosphere. And it's made up of the crust and the very top part of the mantle. Then the layer that's just below that is called the asthenosphere. Try to say that one with me. Asthenosphere. And it's the upper part of the mantle, and it's just below the lithosphere. So first you have the lithosphere that includes the crust and the very top part of the mantle. And then you have the asthenosphere, which if you look down at the diagram below, you see it's that thicker part, and that's the upper part of the mantle that's just below the lithosphere. And remember how I was talking about, when we were talking about the mantle, how as you go closer to the center of Earth, that mantle gets softer. And that's part of the asthenosphere, excuse me. So the asthenosphere is kind of hotter and softer, and it's like that tar that we were talking about before. All right, now remember that the lithosphere is made up of the crust and the very top part of the mantle. Now, the Earth is not one solid piece of crust, is it? It's actually broken up into smaller chunks of rock or slabs of rock, and these are known as tectonic plates. Some of these plates are very large and some of them are small. These plates fit together a lot like a puzzle on the surface of Earth, and they float on top of the mantle. So imagine in your mind having a pool, and maybe you have some pieces of styrofoam that are floating on top of the pool. that's kind of what these plates are like. It's underneath the plates, it's very soft, and so you literally have these slabs of rock floating on top of that softer rock underneath it. Now, most tectonic plates have both continental and oceanic crust. And here we have a diagram of Earth's major tectonic plates. And there are about 8 of them. There are a lot of minor plates, smaller plates, but there are 8 major plates. And let's look at the African plate, the one in the middle. Now, the African plate is outlined in black, and as you can see, the continent of Africa is in the middle of that. Now, what kind of crust would the continent of Africa be? Obviously, continental crust. Surrounding the continent is ocean. So what kind of crust would be under the ocean? Oceanic crust. So together, this entire plate has both continental crust and oceanic crust. And as you look at some of the other major plates, you can see that they also both have continental and oceanic crust. The Pacific plate, for example, is mainly oceanic crust. This is the end of our Layers of the Earth screencast. So if you would please go to the virtual classroom for some follow-up activities to end our lesson with.